The next topic is coefficient of friction, which is denoted by the sign mu. Again, there are two types of coefficient of friction. First is coefficient of static friction and second is coefficient of dynamic friction or kinetic friction. So first we will see the coefficient of static friction, and it is denoted by mu s. Okay, now this part we already studied. There is a block which is resting on table. If you pull this block in this direction by applying the force P, so the force will be, friction force will be in this direction. The weight of block will act vertically downward, that is W. Opposite reaction that we call as a normal reaction will act in upward and perpendicular to the surface, that is R. Okay, so this force, suppose block is not moving, so this force, friction force, we call as a Fs. Okay, that is static friction. Now this Fs is directly proportional to the R. Fs is dependent on this normal reaction R. Okay, or we can denote this as a N also. So how we can write this relation? So static friction is directly proportional to N, that is normal reaction. This we can also write as a Fs is equal to, so there is a constant and that constant is mu s into N. Okay, and this mu s is the coefficient of static friction. Now this mu s you can write as a Fs, that is static friction, divided by the normal reaction. So this is the formula for the static friction, mu s. So when we will use this formula? This formula we use for the impending motion. Means what? When this is about to just start to move, okay, then we use this formula, that is mu s is equal to Fs, that is static friction upon normal reaction. And the second type of coefficient of friction is coefficient of kinetic friction, that is dynamic friction, and this we denote by mu k. Similarly, we can write mu k is equal to Fk divided by N. Fk divided by mu k is the coefficient of friction, kinetic friction. Fk is the kinetic friction. Okay, when the body start to move, whatever the friction is there, that friction is known as kinetic friction divided by the N. Right. Next topic is angle of friction, which is denoted by the phi. Again, there are two angle of frictions. First is angle of static friction and angle of kinetic friction. So first we will see the angle of static friction, which is denoted by phi s. Okay, again we will take the same example of block which is resting on a surface. We are pulling this block in this direction with the force P. Its weight W is acting vertically downward, and opposite to that there is a normal reaction. Okay, now we know the friction force always act opposite in a direction of this friction. So generally friction force is here, okay, along the surface. Here we are looking at angle of static friction, means the body is at rest. So here it is friction force Fs. So this force I can denote here also. So I will redraw this part. So this is my frictional force, this is my normal reaction force. Okay, so what is angle of static friction? So for the static motion, that is for the impending motion, means when the block is just start to move, okay, the angle between normal reaction and resultant is called as angle of static. Now what is resultant? See here it is friction force, and here it is normal. The resultant of these two force is the, okay, we call it as a resultant reaction, that is R. This is normal reaction, this is resultant reaction, this is static friction. Okay, the angle between normal and resultant is known as static friction. So this angle is static friction. Now by geometry, okay, so again I can redraw this. This is normal reaction, this is your resultant, this is your normal, okay, and here it is friction, static friction, okay, and this angle is phi s. Okay, so by geometry we can see tan phi s, okay, opposite is fs, that is static friction, divided by the normal reaction n. Okay, but we know the static friction coefficient of static friction mu s is equal to fs of fs, that is static friction upon n. Okay, so finally how we can write? Tan phi s is equal to, put this here, mu s. Okay, and finally angle of static friction is equal to tan inverse mu s. Okay, so this is our angle of static friction. Okay, and now the second angle of kinetic friction or dynamic friction, and this we denote by phi k. Same thing we can write with respect to angle of static friction. Okay, that is here it is phi k, that is angle of static friction is equal to tan inverse, here instead of mu s write mu k, that is coefficient of kinetic friction. So this is our angle of kinetic friction. Now the next topic is angle of repose. Okay, now so this is a horizontal plane on which the block is resting. Okay, so here we are not applying any type of force. Okay, now what I'm doing, I am just inclining this plane. Okay, let's suppose at particular any angle. Okay, now the block is here. Okay, so at this angle also the block is not moving in this direction. Okay, again I am inclining this, again the block is not moving. Okay, now when I move this block at an angle such that this block start to move in this direction. Okay, so what is happening in this case? The block was horizontal, the plane was horizontal, so there is no question of that block will move. Now I have tilted this with certain angle, still it is not moving. Okay, again I increase this angle, still it is stable, it is in equilibrium. Now when I incline with angle alpha, okay, so just start to move in this direction. So this alpha angle is known as angle of repose. So what is the definition of angle of repose? So it is defined as angle of inclined plane with horizontal at which the body is just on the verge of sliding motion or impending motion. So that angle is known as angle of repose. Now the last topic from this chapter, Introduction to Friction, is the relation between angle of friction and angle of repose. Again we will take this example. Okay, so this is the inclined plane, this is horizontal plane. On this inclined plane this block is resting. Okay, now angle of repose, here it is alpha, angle of repose. So here it is weight of this body which is acting vertically downward, and we denote it by W, right? Then here it is normal reaction which is perpendicular to the surface. Okay, not perpendicular to the weight, it is perpendicular to the surface. Okay, now angle of repose, just we have studied, angle of repose is when the body just start to move. So in which direction it will move? In this direction it will move. Then in which direction friction will act? The friction will act in this direction. Remember that friction will always act opposite to the motion of body or motion of block. Okay, now we will resolve this force. Okay, now we will consider this as a horizontal axis. Okay, now we will resolve this force, one in this direction and one force in this direction. Okay, here it is angle alpha. Okay, so what will be the resolution of this force? W cos alpha, and this force is W sin alpha. We have resolved the forces, okay, that is W cos alpha and W sin alpha. Okay, now we will take, suppose this is in equilibrium, so Fx is equal to 0 and Fy is equal to 0. Okay, so what are the forces in x direction? Summation of all forces in x direction. So this is F, consider this as a positive, F, this as a negative, minus W sin alpha. Okay, so here F is static friction. Okay, so we are considering this as in equilibrium. Okay, that is static friction. Okay, so what is Fs? We know mu s into n minus W sin alpha. So this we can write mu s n is equal to W sin alpha. Consider this is equation 1. Now for the second, summation Fy is equal to 0. So what are the forces in y direction? N, this is downward, W cos alpha, which is equal to 0, and this we can write N is equal to W cos alpha. This is equation 2. Okay, now substitute this value of N in equation 1. Substitute N in equation 1. So what we will get? Mu s into W cos alpha, which is equal to W sin alpha. Okay, so this W and W get cancelled. So mu s is equal to sin alpha divided by cos alpha. Mu s is equal to tan alpha, right? So what is mu s? Coefficient of static friction is equal to tan phi s. Okay, just now we have studied mu s is equal to tan phi s. So put this value here. So tan phi s is equal to tan alpha, and finally we write phi s is equal to phi s is equal to alpha. So what this indicates? Angle of repose, okay, is equal to the angle of friction. Okay, this is the relation between these two forces.